Hi again. So today we'll be doing OpenFOAM simulation for a backward facing step in 2D. Now, in the OpenFOAM tutorial section, you can find the backward facing step in many of the folders, but what we will go for today is incompressible flow, and in that we have our simple foam solver, and under that we'll have the backward facing step 2D. Okay, so this is what we'll be using. So I will copy simple foam from here. I'll go to my working folder. I already have a backward facing step. Let me just delete it. Okay. I'll paste the simple foam folder here. Okay. So backward facing step is what we need. Okay. So under this, again, we have constant system and the O file, 0 file, sorry. So like I said, we do not need the .org uh, file name. So we'll remove that. Under that, we have now of course the usual pressure and velocity, but along with that there is some more values like your k, epsilon, nu, omega. These are all the turbulent flow dissipation parameters or transport parameters that you have. You can vary them if you want, whatever, either k epsilon or k omega, whatever you're going to use, you can change that. For example, if I go into omega here, you can see this is the object omega, and it has a fixed value which is from the internal field of the flow. Okay, so like that you can set it up. Similarly, if you go to epsilon, now this is epsilon, again it has a uniform value of 70.83. This is in the internal field as well. So all of this has been set prior to our analysis. You can change it if required. Under constant, again you will have the transport properties here and the turbulence properties. So if you go to the turbulence properties, okay, so now it is set in the k omega SST. So this is usually what is the best model for your backward facing step. So you can of course change it into k epsilon or whatever formulas you want. Okay, that can be done here. So right now it is set in k omega SST. Go ahead and close this. We'll come back here to the system. Now we have the block mesh deck and the control directory. So let's open the block mesh directory. So this is the geometry of your system that we have. Maybe after meshing it, I'll just show it to you in ParaView. We can try to visualize that. Okay, so there are several kinds of different mesh that has been done. So you have coarse mesh here, then you have fine mesh here, you have simple grading that is being done, you have hex meshes here. Okay, so all the entire mesh is being done here. We can change it if you want, but let's not touch anything for now. It might cause errors for us. So again, you can change the pressure coefficient, you can change the schemes, you can change the solution. Maybe I'll just go into schemes here just to show you. Okay, so this is running in the Gauss linear. It's Gauss linear corrected. Okay, those values we can see here. If we go into solution, okay, this is running by the Gauss-Seidel method. I'm sure you'd have learned in mathematics and numerical methods how to do that iteration, right? So it'll be running in that method. And you can see here it runs in k epsilon omega, whichever we want we can choose that. So either of those are going to be used. So let me close all these and then come back to our folder here. Now I'll open up Ubuntu terminal and I need to find my way into this folder. So I'll hit ls. So this is in simple foam, right? So we'll hit cd simple foam, okay, and then list. So what we need is backward facing steps. So cd backward facing step 2D. Okay, we are in that folder now. Now we can run the block mesh here and it will mesh everything. You can also check the mesh with this command. Okay, it seems one mesh check was failed, so it doesn't really matter for us. Everything else is fine. We'll try to view this particular mesh in ParaView. So let's open ParaFoam for now. Okay, in ParaFoam, we have the backward facing step 2D.foam. Click on apply and you'll be able to see the 3D geometry here. Okay, we just change it into wireframe and we can see the mesh that is being created. Okay, so we have very detailed mesh here at this location. Okay, as you can see, this is the backward step. So here you'll have the flow being changed here. This is a 3D analysis that we're doing. And on the extremities, the mesh is very uh, wide. The elements are very wide. Hence, you might have got some error somewhere. Okay, so let's close this for now. You can use ParaView to view all these things. Okay, so let's close this now. We'll go back to a simulation. So to run the simulation, this is in simple form. So we'll have to just type in simple form and hit run. So this will iterate for the entire time. We did not set the time duration. So it'll run for the entire time duration, after which we can see the simulated results in the ParaView. So let's just wait for the analysis to run. Okay, now that the analysis is completed, let's go to ParaView by the command paraform and we'll take a look at the results. Click on apply and you will be able to see the flow here, backwards facing step. Now this is in times 1600. Let's see the fully developed flow. Here in the pressure, let's try looking at the velocity. Now this is much more clear. So velocity starting from 1600 seconds, 2000 seconds. Now we can change the directions if we want. So let's try looking at the streamlines, if you will. This is not exactly the streamlines. Let me just pan to that area. I'll just zoom into that particular area to visualize the flow there. As you can see, there are some vortices that are being formed in this backward step area. Now you can not only velocity, you can look at various other properties as well. And this is our simulation. Of a backward step flow in 2D. So thank you for your time.